Hello, everyone. Thanks for joining us today. My name is Charles Rice. I'm the host for today's webinar. Today, we're going to be talking about the Simcenter Testlab geometry display. And your presenter for today is Pete Sheldebrand, and I'll be helping out a little bit. Well, with that out of the way, I want to show you the agenda. So some of the things we're going to be talking about today is how to create a geometry from scratch, as well animation controls, maybe show you some that you didn't know existed. We're going to be showing also a vibroacoustic modal visualization. And in the end, we're going to show importing geometry, specifically STL files, universal files, other types as well, and show you something called mode shape expansion. Well, with that out of the way, we're going to mostly be working in the software today. So I'm just going to turn it over to Pete.
Okay, good. Well, I'm in our data acquisition workbook here. This is impact testing, but it could also be something where we're taking operational data. And maybe we want to create a small geometry to represent our test structure in order to be able to animate it. And so one of the nice things is you can actually open up the geometry module while you're in the acquisition to kind of make that a pretty smooth process. If I go to Tools Add-ins here, I can turn on geometry under add-ins, and it's not showing down here, and that's because there's another place here, Tools Workbook Configuration, where you can kind of hide things you don't want people to see. I guess I hid that, but normally it would show up here as geometry. So notice I'm in acquisition, but I got a geometry workbook. If I go over here and I click on geometry, again, we tried to make things easy for you in Testlab here by, we have like, I guess I'd call it a sub workflow. So you got like this main workflow of things that you're doing, but here we have a sub workflow of things that we need to do to create a geometry, or that we can do. And the first one is I can create something called a component. So if I'm making a complex geometry, I don't know if this like table that I'm working on here, I could create one called table, for example, hit accept table. And I'll come back to this, but it could be like there's the table top and then I got the table legs. Those could be two different components. Does that kind of make sense as a concept to you, Charles?
Yeah, break it down into different parts. Makes sense.
Yeah, and then on these two components, I can assign some points or nodes that I'm going to test. And notice it's picked table here, and there's a little trick over here. I can actually switch between adding points on the legs or on the table. And so, I could just type in a few points if I want. And when I do this, it's going to show up. I hit this accept table, and I got 4 points. Pretty cool, huh, Charles?
Yeah.
And I guess, I want to show little features, in the geometry display here. So one little feature is like, I don't know what these points are. I can only, as I hover, I can see what they are, but I can't see them all the time. If I right click here and I pick model, nodes, names, they're on permanently. So I can see the 4 points. Make sense to you, Charles?
Very clear now.
Okay. And then I can go to lines here, and I can connect the lines. Notice as soon as I hover over this, when it turns yellow, I can click and connect the lines. Kind of like being in grade school. I can connect the dots.
Yeah. It sounded like you double clicked on that last one. Was that correct?
Yeah, I did double click, and that's how it knows to stop adding. Like, oh, wait, I want to stop. If I click on it again, notice it's not connected anymore. Or you can actually hit escape.
Okay.
And if you're going to make it even fancier, so for this table, I could say surfaces. And under surfaces, I can add triangles. That means any 3 points I click on get connected here. What do you think? Does that look more like a table, Charles?
It looked like it could hold something now, yes.
Yeah, exactly. Or I could have done that if I delete these 2 triangles here. There is a quadrangles. I think that might be a fancy word for square, but this may or may not be a square. Could be a rectangle, I guess. So, and then I clicked again. twice there. So I could have done 4 points and added something.
Okay.
Yeah, if I go to legs here, I could actually have the same point numbers if I want, because they're on a different component. I could have the same dimensions here, but notice there's this Z direction here. You see how the Z points straight up?
Yep.
Well, the legs should be underneath the table, right?
Typically. Yes.
Okay, so on the height here, I could type in -1, for example. Makes sense?
Yep.
And I can do things in the geometry here, like copy, paste, and I'll hit accept table. And now I got 4 points underneath. And now I can add connections. Oh, I have to go to lines here, and I can add connections to these like that. And now I got my legs, and then, along with the, everything else, we got something that looks somewhat like a geometry. Make sense so far? Yeah, so when I click, it rotates, but if you click and hold down on these, you can move it. And if you click on this, you can zoom in and out. You can also use the scroll bar on your mouse. If you get this thing, in a position where you didn't like it, you can just right click here, pick fit model. It'll maximize it back to where you want. Okay. Now, another thing besides points that I can add in the display is something called Euler angles. This is the orientation. And when you place the accelerometer on, if you got an accelerometer pointing straight up, that means that should be in the plus Z. So you can actually see the orientation of these different points on here. So it's kind of nice to be able to see that. And it is possible on any given node. Let's say for some reason this wasn't a perfectly level table. So table 0.2 here. So I highlight table 0.2. There's actually a rotational angle. So like X to Z here, I could say, hey, this is actually at a 45-degree angle. If I hit accept, notice I rotated that point. See that, Charles?
Yeah.
And that would help me if this surface wasn't very even. I could mount it flush to the structure and just rotate it in the geometry, as opposed to maybe trying to mount it in a weird way or something. And these things, really, if you're going to do a test with a geometry, you could actually make the geometry be the step before the channel setup. And when you get to channel setup here, if you say use geometry up here, you hit refresh, there you have the table. You can grab a point that you're going to test, highlight the channel that you're measuring with it, and pick table 4 here. And I could do the same thing with this table if I was mounting the accelerometer on table 1 and on that particular Excel or whatever. And I would type in the direction. It's kind of makes it nice. You can set this up so that you can just move these points over into the channel setup right off of the geometry.
That is nice, because I'll tell you what, if I've had issues where if that name isn't exactly the same, it will not animate later.
It uses the name, and it's case sensitive too, right?
Exactly.
It has to match the name of the geometry point. So cool. We did that in geometry. I wanted to show some more little tips here. So you ready for another one?
Got my pen and pad. Let's go.
All right. So if I go into the navigator, I can grab the geometry, right? Put it over here. And if I go to options, let me see if I can find this one. My table's looking a little weak. These legs look a little thin. Right?
Might not be able to hold much. Yeah.
Yeah. So you can actually come in and you can say, hey, I want to make the legs a cylinder. And I think you can make them thicker. Uh-oh, I didn't pick the right thing there. Let's try the form main model. Okay, there we go. What do you think now? Did I make my table
Oh
a
yeah,
little more
yeah,
hefty?
yeah. Looks like we could charge a little more for that one now.
Yeah. So I guess another little trick, if you're doing something real simple like this, and you can import fancy CAD models. You're going to show that later, Charles. But
Right.
I gussy up, this real simple geometry I was making. I can use this cylinder for doing that. How do I show the point numbers again, Charles? Do you remember?
If we right click and go to nodes, and then names. There you go.
Yeah. Now they're a little small, a little hard to see.
For my eyes, for sure.
Little trick here is that under node marker, you got a font size. I can say large here so that I can see them a little bit better. And you can also do things like play around with the background colors. So I can make the background light if I want. I could make the text be darker, for example. So there's a lot of nice little things you can do there, Charles, to, play around and, with your aesthetic eye, set things up the way you like it.
I can read it now. Thank you.
Yeah, no problem. I'm going to go to geometry and I'm going to wipe this out. Okay. I'm going to undo all that good work. Let's say I had a circular tabletop,
Sure.
Instead of using Cartesian coordinates here, I could pick cylindrical. I guess I wanted to show that there's this cylindrical option. And here too, I can put nodes on. So I can say 1, 2. And by the way, if you have something like this, you can actually pull down and it'll auto increment.
50.
But now instead of X, Y, Z for my coordinates, I have an R, theta, and Z. Any idea what those suckers are?
Radius, angle for
Radius
theta.
and angle. So
Yeah.
like I'll make something all the same radius, but I could say 15 degrees here for my angle. So I have 0, 15, and maybe I'll use that feature here. I got everything incrementing by 15 degrees. I'm going to hit accept table. So what did I create there, Charles?
We were trying to make a circle there.
Yeah. Now I can't see the circle. What was the trick to get this in view again?
Right click, fit
model. Fit model's my friend. So we only went part way around the circle here, but you can see, or it should give you an idea of how cylindrical works. Constant radius, 15 degrees apart, and yeah, you can go in and create lines here. Now I think when you go to channel setup, and you say like, okay, I got this cylindrical system, table 15. I can shoot that over. The directions, though, they don't have R, theta, Z. They still say X, Y, Z. So what gives with that, Charles? How do I pick for table 15?
We can use the Euler angles here.
Yeah, let's turn on those Euler angles like we had before. I'll turn on the names. I'll turn on the Euler angles. And what's interesting is, again, blue is Y, green is X, and red is Z. And we can see that the X direction is coming out of the surface, right? Perpendicular to the surface.
Yeah.
So accelerometer, if I mount it to this cylinder and I mount it so that a particular direction is coming out, I would mark that as plus X, right?
Yep.
So it's still X, Y, Z. And you can actually see the X, Y, and Z here. And they're just kind of like rotated for each one of those points. And if you're on the tangential, it would be the Y. If you're along the surface there, it would be the Z. Let's look at something a little more complicated as far as the geometry goes. And we'll go, let's see. What do you think of this geometry, Charles?
Pretty nice looking with the convertible.
Yeah, I guess it's a convertible. Again, we could gussy it up with some cylinders or something, but I'm going to throw some modes in here. Take a look. There's some kind of twisting mode.
Yeah.
Now that thing's kind of moving pretty fast, and maybe over WebEx you have trouble seeing it update quick enough depending on your connection. So I guess I wanted to show, like, when I'm animating something, there's a whole section when I right click on animation, and under animation settings here I can say, hey, let's take a little longer delay between frames. Did that slow down for you, Charles?
That slows down on my screen.
Yeah. And you can also say how many, it's doing 12 chunks per cycle of this mode. I say 20, now the animation will be a little bit smoother. Did it kind of?
Yeah, definitely smoothed out.
Yeah. So we can slow down and speed up the animation there, which is kind of nice. And we can see also, maybe we're interested in this engine that's bouncing around and its modes, but it's a little hard to see. And that's where component visualization can come in. So we did different components earlier with the legs and the tabletop, but I can come in here and I can say, hey, I want to turn off this. I want to turn off the front. It looks like this is, I'm guessing that's the rail. Yeah. And now I can just see the engine more by itself. So component visualization makes it easy on these complex geometries to kind of focus in on one part of the
I see the value of making components now instead of putting it all in one.
Yeah, with a table it wasn't that exciting, but with anything relatively complicated it is. There's also a translation here. So the other thing I could have done with that engine is, I can see there's a Z direction here. If I grab this translation here, I can make the engine float out of the structure so I can see it.
Kind of exploded view type of thing.
Yeah, like an exploded view. Or you could tell the person, oh no, the engine wasn't installed properly. So that makes some sense there, Charles?
Makes some sense.
So I'll put it back in though.
Yeah, that makes more sense.
This texture actually is kind of interesting too. If you have like a little animated, like a little picture, you can actually grab, I don't think I have a good example of it, but you can grab a photo, like of a wood grain or something. Like if you wanted to make this an old-fashioned wood station wagon, and you could actually have a picture on the surface rather than a JPEG file of some sort, rather than this plain color that you have to select here. So
no,
make it a little fancier too.
Yeah.
Okay. Let's switch to another project. You like this animation?
Oh yeah, we got some stuff going on those days.
Yeah. Oh, by the way, a lot of people when they first see a mode shape, they're like, "Oh my gosh, is the car moving that much?" And you have to say, "Well, no, you can't really see it like that. This motion is exaggerated." And of course, under animation settings here, under deformation, actually, you can change how much that moves. And so there's a deformation scale, right? And then you got a bar here. I can make it move a lot, or I can make it move a little, because it's kind of a relative motion. You control how much motion you see.
Got it.
So let's grab another mode shape here. And what's interesting, when you drop these, you could, if I drop it here, I replace the current mode shape. So this is 31 hertz, right?
Right.
Again, now I got the
27. Yep.
But when I'm dropping it, you might have noticed it says main there, and then there's this highlight area. You can actually overlay these modes. So I'm going to drop it in the back here. Now I can actually see both modes at the same time, Charles. What do you think?
That is very cool. I like that.
Yeah,
A little difficult to
and
compare.
yeah, a little difficult to compare. And you know, the front here is kind of out of phase, is one thing I noticed. And in fact, when I'm
Yeah.
playing two mode shapes, there's actually under this animation control, there's a setting here. I got the two modes going, and really the phase is kind of arbitrary. I could say, hey, I want to space these 180 degrees apart. Now, how about the fronts? What do they?
Okay. Yeah.
Yeah, I
That
can
helps.
make it so, yeah, those two parts are moving the same in
Yep.
phase, and then I can see the differences in the rest of the structure. So I can, if I'm overlaying two shapes, I can change the phase between them to kind of like make it a little more meaningful of an overlay if I want.
Oh, that's a useful tip. Thanks.
Yeah, I like it. I use it all the time because I'm comparing mode shapes constantly. Not really. Well, okay, so now I got
More than the average person.
another mode shape here, and yeah, it's moving. And I guess another thing I wanted to point out, that animation control has some other things besides the phase. It actually has some controls. So I can stop this from moving, and this sometimes people want to do. You can single step through the animation, one frame at a time. And you can basically, sometimes people want to see the extreme deformation and look around, and they do the extreme deformation to the other side and look around. So you can like freeze frame it and step through one step at a time.
It's handy too.
Yeah, it is. There's some other things here like colors and stuff, but I thought maybe you'd want to show that, Charles, because you're
Okay.
some little tips too.
I can show some color.
All right. Oh, I forgot. Why don't you show yours? Well, I'll show my other stuff here. I'm sorry, Charles, before we switch to you. I want to show another type of animation with color, actually. This is a mode shape, but instead of moving, it's set so that the animation is in color. You see the deformation is off here? If I turn deformation on, you see it moving.
Yeah.
But in this case, we actually took data in the air cavity of this vehicle. And in reality, like the sound, there's no structural deformation in the air. It's just the sound pressure, the amplitude of the sound pressure. So, so really, the way sound works, you probably shouldn't see it actually move, although we allow you to assign a direction and move it. But you can actually set it up so that the colors, so you turn on coloring, so I enable that, and it shows the sound pressure levels of the mode shape. And you can do things like, hey, I want to see just the absolute amplitude. So now it's not even moving. This is the maximum amplitude that the air moves at any given location. So I can actually see that for this acoustic mode if I want. And I can also do the same thing, this, look at it in dB, look at it in a variety of ways, including with the phase. All right, so that kind of previewed colors a little bit, Charles. We'll let you
Okay.
show us this maybe on a little fancier animation.
Let me switch screens. So you definitely did a good job showing us how we can create a geometry from scratch and putting in the components, breaking it up so that we can use that component visualization later and different coordinate systems, but maybe we want a quicker route sometimes. And what you can do is you can see over here on the left-hand side, there's this import geometry. Now, all I need to do is browse to wherever the geometry might be on my computer. In this case, I already have a link to a directory where I have a lot of different geometry files. You see I have a universal file, I have a Nastran, OP2 file here, and a couple STLs. And all I would need to do is click on the geometry, hit the import. So it'll ask me, hey, do you want to replace your current geometry? So I'll hit yes, and you can see this is a rim, some wheel that somebody created and just exported as a universal file. For example, something a little fancier. Someone gave me this stereo file. We can import that, and it's a little bit bigger. It's the Eiffel Tower. Something a little fancier, maybe a little exciting and
I
fancy.
do hear you. Can you hear me?
Yes, I can hear you now. This is a jet fighter, right? And the reason I brought this one up is because I wanted to show you something else we could do. Let me switch to another project. So one of the advantages of being able to break up your geometry into components, we can make a wireframe, and we can also have a more detailed model. And for example, let's say you did go out, did some measurements, collect a lot of FRS, did your curve fitting, and this was the wireframe you used, and you created these mold shapes, and you can animate it. And you, as the person who took the measurement, made this wireframe, this makes a lot of sense, right? It's easy to know what's going on. In this example, it's relatively easy too. We can clearly see the wings, the tail, right? Fuselage here. But if you wanted to have something maybe a little bit easier for someone who didn't create the wireframe to understand what's going on, what we could do is, going back to that component visualization that Pete showed us, I had another component here, and it's a more detailed model, right? It's an STL file of that jet fighter plane that I brought in. Now, as you can see though, that STL file has a lot more points that I didn't measure. Maybe there's like 3,000 points in that file, but we measured far less. We did our wireframe to do our modal test. But that doesn't mean that we can't animate those points. We have a function. If you go down here, right click, go to animation settings, go to automatic geometrical, and you'll see I'm able to animate the rest of those points, those nodes, right? What the software is doing is all those nodes that made up that more detailed STL file, they're being animated by the nodes from my wireframe, and it depends on how close they are in relation to the wireframe nodes for it to interpolate the motion. And one nice thing about this is that this way, if you do animation settings geometrical, it's going to work off the nodes, but if you use topological, it would be based off the lines that you connect from your wireframe to your detailed model. We actually have a nice article on our website that kind of explains how to do it either way. Pete, do you still hear me?
I do hear you.
I'm just used to you having a lot of jokes. Even I got this model from Bill actually, and he actually had some video footage from the actual test too, so we can see how representative our model becomes when we use that. It's a little lame joke here.
Oh, that's a good one though. I'm impressed.
But yeah.
Now I know how a plane flies.
Now you know how a plane flies, exactly. I think that's all I really wanted to show with regard to importing geometries and using the mode expansion.